Alrighty, for this one, let's talk about pH. pH is a property of solutions, and it has to do with um, the acidicness or the basicness, acidity or basicity of your solution. Okay, and we're just going to kind of skim the surface of pH today, and in Gen Chem 2, we'll come back and do a lot more with pH in more detail. Okay. Um, pH is due to the hydronium ion. Hydronium ion is one of our polyatomics that we've talked about. This is H3O plus. Um, and as we'll see in a bit, and think we've seen it before when we talked a little bit about naming acids, things that are acids tend to produce an H plus ion that's in solution. Okay. This is a free proton. Okay. Um, and something we should remember about this is that the proton in solution is not really just free floating around. There's no just H plus ion if you're in an aqueous solution. Because what happens is the H plus ion is drawn to these lone pairs on the water, okay? And you have a really strong hydrogen bonding action, and it just grabs those hydrogens and makes water. I should have drawn this out as a Water-Lewis structure, but you know what I'm talking about. And it just draws things out to look like this. Okay, so whenever we're talking about H plus that's aqueous, we're really saying that this is a hydronium ion H3O plus. And for now, for most of Gen Chem, we can kind of think of H plus and H3O plus as interchangeable quantities. It just differs on how we're going to balance equations and work with some stuff that way. Okay. All right, let's take a stab at looking at some of this stuff. pH is a log scale, and it's a log scale because it's letting us think about representing very small amounts of H plus or H3O plus. Okay, so if you want to think about it, if you have if you have 0.10 molar H3O plus, you're gonna have a pH of 1 because you have 10 to the minus 1. Okay, this is a really high concentration of H3O plus for a solution. And so the more and more dilute you get, the smaller and smaller your concentration is, the more the pH goes up. And that's because our pH is always equal to the negative log of the H3O plus. And so what I want us to get used to here is, can we pick out if a solution is acidic, basic, or neutral? Okay, among other things. So when we're talking about something that's neutral, neutral just means it behaves like pure water. Okay, it's not acidic or basic. Okay, in Gen Chem 2, I'll teach you that that means that the H3O plus is equal to the OH minus. In terms of concentration, the amount of H3O plus is equal to the amount of OH minus in solution. And a neutral solution has a pH of 7. Okay, we can see that right in here. Okay, the neutral solution has a pH of 7. This because the H3O plus is 1.0 times 10 to the minus 7. Okay, if your pH is less than neutral, less than 7, then your solution is acidic. I don't know why my pen's doing weird things. Okay, and if your pH is greater than 7, your solution is basic. Okay, so we kind of want to get a feel for what the pH scale is telling us, right? And where things are. A pH of 0 is roughly what hydrochloric acid is. Your stomach is very acidic, pH of 1. Lemons, acid rain, wine, a lot of fruit, coffee, all this stuff is acidic. Pure water, there's our neutral, pH 7, right here. Okay, and you keep going, and things get more and more basic. A lot of cleaning products, hair removers, pure sodium hydroxide are very basic. Okay, and so we want to kind of have a grasp. Mostly, I just want us to grasp the relationship between pH and concentration, and whether or not something is acidic or basic or neutral. Okay, uh, let's look at some example problems. What is the pH of something when the concentration of H3O plus is 3.5 times 10 to the minus 4? Okay, we're gonna have to memorize this pH equation. So pH equals minus the log of H3O plus, and I didn't say it earlier, but I'll say it now. Um, when you're writing an equation and you have these square brackets in here, the square brackets is just meaning the number we're presenting, or the piece of the variable we're looking for, is molar concentration. Okay, so here pH is the minus the log of the molar concentration of H3O plus. Okay, so if I tell you we have an H3O plus concentration of 3.5 times 10 to the minus 4, then we can say that our pH is equal to minus the log of 3.5 times 10 to the minus 4. Okay, we don't need units on here because pH has no unit. Let's make a note of that too, because that'll be delightful for us. pH has no unit. Good. All right. So if we're tackling this, right, we also kind of want to kind of make a guess here of what we're talking about. 10 to the minus 4 is greater than 10 to the minus 7. 10 to the minus 7 is neutral. So that means 10 to the minus 4 should be acidic. So we expect a pH that is less than 7. Okay. And when we do this, 10 to the minus 4, 3.5, what do we get? We get 3.455932. That's a crappy looking 5. Okay. And then we're going to round this to say 3.46. Okay. Typically, pH is presented with 2 decimal places. There is a significant figure rule here that deals with logs. I don't care about it right now. If you're curious about it, ask me in class. We'll talk about it. Okay, it's fine. This pH is acidic, which is what we predicted, so this makes sense. Okay. All right. Oh, that's not what I wanted. Let's do another one. Okay, a solution has a pH of 10.56. What is the hydronium ion? Excuse me, what is the hydronium ion concentration? I'm sorry, I didn't mean to go on. Okay, again, we need to write our pH equation. pH equals minus the log of H3O plus. All right, now we're looking for H3O plus. Okay, which means we need to figure out how to get rid of the H3O plus. Okay. I'm trying to think of a good way to explain this. Um, if you think about it, the log of something 10 to the x is equal to x. Okay, so what that means is if we have the log of x, well, this is going to be equal to, is that true? Yeah, 10 to the x. Because if we take, let me start this over. All right. If you want to solve for a number in your log, okay, never mind. This is why I don't teach math. Okay, just learn this. That I'm tired and still feel kind of crappy. Okay, all right. The inverse of log is 10 raised to a power. And hopefully, I might as well just probably redo this video, but I'm not going to. All right, so our H3O plus is going to be equal to 10 to the power of the negative pH. Okay, 10 raised to a power is an inverse of log logs. Okay, that's a weird thing about exponents. We can talk about it in class more when my head's on straight. Okay, we're not going to stress about it too terribly much. But if we're solving for H3O plus, oh crap, it looks like this. Okay, and we were given pH, so we can just stick the pH in there. So our H3O plus concentration is 10 to the negative 10.56. Okay, the 10 raised to a power is a function in our calculator. And so we'll put this in scientific notation and say this is 2.75422287 times 10 to the minus 11. And now we have a concentration, so we need concentration units back on here. And we'll round this to 2.8 times 10 to the minus 11 molar. Okay. We want to remember how to get back and forth. The why isn't as crucial as how this works as to just know that this is how this works. Um, and we'll do some pH problems in class 2 as well to help solidify this with us. Okay. If you need me for anything or have any questions, just let me know. I'm here. Have a good one.